Hey guys, welcome to the video on 13-6, the tangent function, the last section of chapter 13 that we're going to look at. The aim for today is going to be to graph the tangent function. So we spent quite a bit of time talking about sine and cosine, and then moving on to sine and cosine with transformations, and now we're going to extend our graphing to the tangent function. So to do this, we do have to review a little bit. So we're given a point on the unit circle. How do we find the tangent of theta? Okay, so now this is graphed for us, so we just have to kind of review how to find the tangent. So there's a few things we know about tangent. First, we know in terms of a triangle that is the opposite side over the adjacent side. Okay, so now if we have our terminal side drawn, we know we could drop a vertical line from the point to the x-axis to create a right triangle in which we do have an opposite side and an adjacent side. Okay, now what are the values of these? Well, looking at this graph, remember the opposite side is going to correspond to my y value, which in this case is radical 2 over 3, because if you look going to the y-axis, right, that's the distance from 0 to my point. My adjacent side is going to be in line with my x value, which in this case is negative radical 2 over 2. So another way we can look at this is as y over x. So either way, to calculate this, we're going to have to put radical 2 over 2 and divide it by negative radical 2 over 2. Okay, so now we change, and we flip. Lucky for us, a lot of things cancel, and we end up with a negative 1. So the tangent of this angle is negative 1. Now, there is something else that we can use to calculate the tangent, and it comes from the fact that we're on the unit circle. If we remember, the point on the unit circle, yes, they are an x and a y value, but they also represent the cosine and the sine values of a particular angle. And again, this is just for my unit circle. So the third way that we can represent tangent specifically on the unit circle is sine over cosine. So we could use any of these equivalencies to make our calculations. So looking back at the unit circle and how we calculate this, where will these formulas cause us a problem? Okay, now what do I mean by a problem? Well, I mean a value that we will not be able to calculate. Well, we know how to work with radicals, we know how to work with fractions, we know how to work with negative numbers. So all of these in between don't cause us any problems, okay? But something that we cannot have is a denominator equal to 0, okay? So what cannot happen is our cosine of our angle cannot be equal to 0, and on the unit circle, my x value cannot be equal to 0. So which points on my unit circle are going to cause us the most problems? Well, that's this point right there, because that has an x value equal to 0. And this point right there for the same reason. So what angles have tangents that are not able to be calculated? And that's going to be 90 degrees, or in radians, pi over 2. And we're going to be sticking more with radians as we move forward. And 270. Or in radians, 3 pi over 2. Okay, so anytime we get those answers, we're going to end up with something that is an undefined value. Right? So the tangent of pi over 2, as long as your calculator's in radians, should give you an error. Right? If you type it into your calculator. Tangent of 3 pi over 2 should give you an error because it is undefined. And any other value that is coterminal to either 90 or 270 will also give us a problem. Okay, so now if we look at the way the unit circle is structured, it looks like that every 180 degrees, right, we are going to get to another coterminal angle of either 90 or 360. Okay? So if we want to find more values that don't work, if we're working with degrees, if I add 180, it'll give me 270, which we know doesn't work. If I add 180, it'll give me, what is that, 450? 450? That's not going to work, right? And if we're working with radians, we can do the same thing with pi. 3 pi over 2 plus pi would be 5 pi over 2. So these are all going to be values that don't work. So that pi value is going to be important because we're going to be working on the graph. So on the picture here, I have the standard graph of tangent of theta. And you should notice that it does not look anything like our sine or our cosine graph, right? It doesn't have those waves, right, that bounce up and down between a maximum and a minimum. In fact, it has some weird features that we've seen before called asymptotes that we are going to have to make sure we graph appropriately, okay? So remember how I said pi is going to be important? Well, that's because the period of a tangent function is going to be pi, as opposed to 2 pi for our sine and cosine graphs. And that's because it takes pi radians to complete one full cycle. Okay? If we're in degrees, that's going to be 180 degrees. The graph for this one will have vertical asymptotes at pi over 2 and 3 pi over 2. Again, because those are the values that give me 0 in my denominator. So how do we draw those? Well, typically, we've worked with all kinds of asymptotes. These are vertical ones. We draw them with dashed lines to show that they exist, but that they are not a part of our graph, and everything falls in between. Okay? Now, if we were to draw, this would be the graph of tangent from 0 to 2 pi. Notice you have one full cycle and then kind of a broken up cycle on either side. So it's not going to be as pretty as our sine and cosine graphs, but we're going to work with them. Now we can graph as many of these in a row. Notice they all have the same pattern, right? They have asymptotes on either side and then the curve. Asymptotes on either side and then the curve. Okay? And each one of these, as long as it's the basic tan graph, will be pi units between each asymptote. Okay? So now let's talk about what happens when we multiply values in this. So suppose you have y equals a tangent of b theta, where a is not equal to 1 and b is a positive number. Okay, so we're only working with positive frequencies right now. And of course, being in radians is going to be important, especially if we're working with our calculators. Pi over b is going to be the period of the function. Different from sine and cosine where it was 2 pi over b. Okay, and that's because for the standard trig graph, pi is our period, so we want to divide that by the frequency to see how many to see how long our single cycle will be. The other thing we need to be able to calculate are the asymptotes, okay? So one cycle, if you look at this interval right here, from negative pi over 2b to pi over 2b, you should be able to see one full cycle, okay? Now, why is that important? Well, at the end of this cycle, you will see the vertical asymptote. So basically, if you find negative pi over 2b, there should be an asymptote, a vertical asymptote at that value. And if you look at pi over 2b, you should see another asymptote there. Okay? So that's where we're going to start. You're going to look for the interval one cycle occurs and find the asymptotes that occur at these values. Okay? Draw them out. Give yourself a starting point for your graph. The rest of the graphing is going to be very similar to the sine and the cosine, right? We're going to have a period. We have to find it. We're still going to divide it by 4 because all the major points, right, of our tangent functions are going to be is going to be divided up into 4 parts, okay? And we're going to find a pattern. Now, the pattern's a little bit different in that it goes asymptote, then your negative a value, then your 0, then your a value, then your asymptote. Okay, so that's where your a value comes into place. And again, the a value is really just going to be a vertical stretch or compression. So if it's bigger, right, you'll see a little bit of height with those a and negative a values, okay? But it's going to follow the same pattern. Now, you can keep repeating that for every cycle you want to draw. So let's dive into it. Let's graph our first one. So it says graph 2 cycles of the graph on this particular interval. Okay, so we're going to actually worry about that at the end. We're going to first focus on graphing the basic function here, and then we will talk about how do we extend it to this interval. Okay, so what's the first thing we should do? We should identify our a value and our b value, right? What's the number in front? Well, there's just a 1 here, so that's good. What's my b value? 3, okay? So what are we going to do first? Well, let's find the interval for which we can graph one full cycle, okay? Let's see where those asymptotes are going to occur. So if I take negative pi over 2b, we're going to get negative pi over 2 times 3. So that's pi over 6, and pi over 2 times 3 will give me pi over 6. Okay, so we should see one full cycle in between negative pi over 6 and pi over 6. So we will see asymptotes at these values. So x equals and x equals, those will be our asymptotes. Okay, what else do we need to know? We need to know our period. Now, for tangent functions, our period is pi divided by our b value. So in this case, it's going to be pi divided by 3. So we should see one full cycle every pi over 3 units. Okay, which makes sense because there's pi over 3 units in between negative pi over 6 and pi. Okay, so now just like we did with the sine and the cosine, we're going to take this pi over 3 and divide it by 4. Okay, that's the same as multiplying by 1/4. And we get pi, over 12. Okay, so every major point, right, is going to be pi over 12 units away from one another. Okay, so to make our lives easier, we are going to make our interval, right, each box on my graph is going to be equal to that value, right? So that way I know that at every point at every x value, I can plot a point. So now let's make this a little bit easier for ourselves. We have pi over 6, we have pi over 3, we have pi over 12. They're all different values. Who knows how they compare to each other? What I'm going to do is I'm going to make them all have the same denominator, okay, so that it's easier for me to plot this on my graph. So pi over 12 is one box, so let's make each one of these have 12 as our denominator, right? So if I want this to have a 12, I need to multiply by 4 by 4. So that's equal to 4 pi over 12. This to be equal to 12 is times 2 times 2, so that's 2 pi over 12, and negative 2 pi over 12, okay? So that kind of gives us a context. So every line on this is going to be equal to pi over 12, so then as we move up, that would be 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12, 6 pi over 12, 7 pi over 12, and you get the idea, okay? So now where does my graph end? Well, let's also make this have the same denominator. So 2 pi over 3 times 4 and 4 would be 8 pi over 12. So we want my graph to stop at 8 pi over 12. Okay, so that's going to be the place where we focus our graph. Now to start, let's start plotting the values we need. I'm going to start with my asymptotes. Now, I notice I have a negative asymptote, so I'm going to actually extend this to the other side. I will eventually erase it because it will not necessarily be a part of my graph. Okay, so where are my asymptotes? At negative pi over 6, I'm going to use a different color, which is the same as negative 2 pi over 12. So that's here, asymptote. and positive 2 pi over 12. That's my other asymptote. Okay, so my graph should be within these points. Now, every major point that we plot is going to be pi over 12 units away from each other. Since each box is equal to that, that means each one of these lines is going to represent a major point. So what is the pattern? It's asymptote, negative A, 0, positive A, asymptote. So negative A. So let's label this axis because we actually haven't yet. Let's give each box is equal to 1. So that's 1, 2, 3. 1, negative 1, negative 2, negative 3. Okay, so we have our asymptote. Then we have our negative A, which would be here. Our 0 would be here. Oop, that's not 1. And our positive A would be there. So all that's left is to connect the dots to sketch my graph. So now remember, it's a curve, so it should be rounded. And the ends of my graph should go along my asymptotes. Okay, so we should be getting closer and closer to my asymptotes. So now that is one full cycle of my graph. But does it satisfy the directions? Well, the direction asks for 2 cycles, and it asks specifically between 0 and 2 pi over 3, which is 8 pi over 12. So we have to continue this pattern until we get to the end part. Okay, so let's do that. Now, there were 4 boxes in between these 2 asymptotes, which we counted. So that means every 4 boxes we will get another asymptote. So that's 1, 2, 3, 4. Right there. Right there. And then 1, 2, 3, 4. We would have another one over here, but we actually don't have to graph all the way to that point. But it will help us guide us. Now we do the same pattern, right? We have negative A, 0, positive A, connect. And again, negative A, 0, positive A, connect. Okay, so that's 3 full cycles that I have here. What's left for us to do is to make sure we are following our directions. So we want to start at 0, which means I don't need anything in this negative section. So I'm going to actually start erasing. So that can go away, that can go away, right? And this right here can go away, starting at 0. So we only have the top part of my graph there. And we're going to end at 8 pi over 12. So what can I do? Well, I can start erasing is what I can do. I end here, so that means everything up here I don't need. And this asymptote I do not need. And there you have it. Do we have 2 cycles? Yeah, it is split up, but there are 2 cycles. We have our asymptotes graphed. We have the points graphed. Okay, so a big help for this, a tool that I use is making sure all my units have the same denominator, just so that way I know that I'm working the pies appropriately. Okay, it helps me label my graph. It helps me to space it out properly. Okay. I would like for you to pause the video and to give this one a try. When you're done, unpause it and check your work. Okay, so where do we start? Well, we know we're only going to need from 0 to 4, okay? But we're going to start first by finding that interval where 1 cycle occurs, even though it has a negative number, because it's a place where we can start. So that is negative pi over b, 2b, and pi over 2b. So what is my a value? 1. What is my b value? Pi over 2. So let's do the math. Negative pi over 2 times pi over 2. Well, these 2's cancels, leaving just a pi in my denominator, and then those pi cancel. So we actually get negative 1 for this. Pi over 2 times pi over 2 cancels, cancels. We get positive 1. So we should see a graph, 1 full cycle in between negative 1 and positive 1. So what does that mean for my period? Well, if I take pi and I divide it by pi over 2, right, keep, change, flip, we get 2 is our period, which makes sense because the distance from -1 to 1 is 2 units. Okay, so notice for this particular graph, my x values are going to be 1, 2, 3, 4, like we are used to. Okay, and that's because the pi's cancel out. So that's a big determining factor on whether you're going to be labeling your graph with pi over 2, pi over 3, etc. versus 1, 2, 3, 4 as if the pi's cancel. Okay, what else do we need? Well, now we need to take our period, which is 2, divide it by 4 so we can find out where all the major graph features happen. So every major graph feature happens half a unit away from one another. Okay, which means I should have my scale at least be 1 box equal to 1/2 a unit. Okay, and that's exactly what I'm going to do. So if each box on my x value is 1/2 a unit, that will be 1, 2, 3, 4, and this will be -1, -2, -3. Oops. Now, let's start graphing. Where are my asymptotes? My asymptotes start at -1 and end at +1. Okay. Each box is equal to 1/2, so I don't have to worry about counting. I know that each box will have a major point. And where did the major points go? Well, my a value is 1, so let's label it the same. -1, -2, -3, 1, 2, 3. We follow the pattern. Asymptote, -a, 0, +a. Connect, arrows, connect, arrows. Repeat the cycle until we get to 4. So how many boxes to the next asymptote? Another 4. 1, 2, 3, 4. Okay, or think of it, it's 2 units away. Okay. And we follow the pattern. Asymptote, -a, 0, +a. And continue, right? Asymptote is 4 units away. And follow the pattern. -a, 0. Now we see that we're stopped at 4, so we actually don't have to continue. We can stop our graph right there. So all that's left is to make sure we are satisfying that 0. So I'm going to erase what I don't need. And that's everything on this side. And there you have it. 2 full cycles of this graph based off the information that we have.